Hello guys, let's begin. Welcome you all to Mastering the Basics of ROS2 with Turtlesim. We will begin the session now. In this session, what we will be covering, I just want to share it with you guys. In this 2-day bootcamp, we will be covering ROS2 command line tools, that is all the basic commands related to ROS2. We will be covering nodes, topics, messages, services, everything. We will be covering how to write our first Python node, and we will be creating ROS2 packages. We will be seeing what are the debugging tools available in ROS2, like RQT Graph. And this session will end with 2 capstone projects. So that will cover all the concepts. So this workshop is not about theory, it's about building, and it's kind of a project-based approach where you learn while building projects. So let's move forward. Also, at any point, if you guys don't understand anything, just raise your hand and I'll ask you to unmute and ask. Okay. So you guys have introduced yourself. Now I would like to introduce myself formally. So my name is Kumar Utkarsh, and I am an electronics and telecommunication engineer by degree, but I am a robotics enthusiast by heart. And I like to identify problems in real life and build end-to-end products or solutions for it. And currently I work as a research assistant at IIT Bombay in the National Center for Aerospace Innovation and Research Lab. And we will be going by this motto in this workshop, that don't chase success, chase excellence. Success will follow. People who have seen Three Idiots movie will resonate with it. So this will be our mantra for this 2-day bootcamp. We'll be chasing excellence. Okay. So now let's get forward. Having said all these things, I would like to tell you guys why I can share my knowledge with you guys. So I have been in the place where few of you guys are. I was a beginner. I searched for resources. I didn't get any. So I looked here and there. And then over a period of this time, I have curated all the knowledge and experience in one place, and I'm willing to share it with you guys. So also, I am a practitioner of robotics myself. I work on industrial grade robots and also build them. So having said that, I would like to share a few of my projects I have worked on with you guys. So this was the first project which I made using ROS2. So this is a bumper bot. So this is a 2-wheel differential drive robot, and you can control it with joystick. And to a twist, I have added a camera to it, with which I had made this line following robot. So it was kind of a digital twin. It worked in real life also and in simulation as well. So this was my first project using full stack ROS2. This was the second project. This is an entirely simulation based project which I built. So again, this is a 2-wheel differential drive robot, but it also has a 4 degree of freedom robotic arm on it. So it also has manipulation capabilities as well. So it is purely simulation based. It has autonomous docking and nav2 integrated vision and all those things, move it, everything. So this was another project. Besides that, I have also worked on projects related to embedded systems and IoT. So this was a project when what I built back when I was in my college. So my college had this problem of making payments. So making online payments was quite difficult. So I came up with a way wherein you just have to make online payment once and recharge your ID card, and then continuously make payment using your ID card without internet connection. So this was a system I built from scratch. So this had 2 components. One was to recharge your ID card, wherein you scan the QR code, make the payment, and recharge your ID card, tap and recharge. And the other machine was wherein you can select your food on your own and then just tap, and it will get the money will be deducted from your ID card, and the order will be placed, and the bill will also get printed. So this was embedded systems and IoT project. Um, and also this is not a project, this is a product which is currently being used at my college. So yeah, And again, this was a project I built back when I was in college. So it is a pill dispensing system for elderly people who have to take a lot of medications. So I built a system wherein you can just, for 1 month, you can set the pills as to when you want to dispense the pills, and it will dispense that pill at that time, so you don't have to remember it. It also has second mode, like a vending machine, wherein you can select the symptom which you are facing and it will dispense that pill accordingly. So it involves IoT embedded systems and also 3D designing. I designed the model using Fusion 360 and printed it. So coming to the last project, this is a purely digital electronics and analog electronics based project. So again, I built this when I was in my college. So this is a visitor counter which I built. So it doesn't involve any coding. It is purely electronics. So it has various sections. It has an IR section wherein I created my own IR sensors using operational amplifiers. It has counting section, it has the screen section, and many other things are there. I'll not go into the details, but yeah. So this was the project, and now I would like to share the current project that I'm working on, which is more relevant to you guys as well. So this is the current project which I'm working on. So I'm working on building an autonomous mobile manipulator robot. So the three photos which you can see are the base chassis or the mobile part which moves around, and the top and the right side photo is the upper body which I have added. So I am kind of working on building a embodied AI kind of a project wherein this robot moves in the house as a personal assistant. It will also be having two arms attached to it, and you give command and it will execute that. For example, you just go ask it, can you bring a glass of water from the kitchen? So it will autonomously navigate to the kitchen. It will identify a glass of water, pick it up, bring it. So this is a very ambitious project, but I am working on bringing it to life. So, having said all these things, having shown you all the projects, so now I think I have built sufficient credibility that I can offer this boot camp to you guys. Okay, so let's move forward. So first, we will be looking at what is ROS2 and why should you care. So I would like to know from you guys who all have worked with ROS2 before. Just reply in the comment section. Yes or no. Okay, so the most of you guys have not worked with ROS2. Okay, so let's go like that. So ROS2, the full form of ROS is Robot Operating System. So what is it and why do we need it? So basically ROS is a framework which we get to build a robot from scratch. For example, the robot which I showed you guys just now. If I were to build that robot entirely on Arduino using C++ or everything from scratch, or even the Unitree robots or the Spot robots, the Boston Dynamics Spot, the dog robot which they have, if you were to build that robot from scratch entirely in C++ and firmware development, it would be a nightmare. Like, for people like us who are just beginners, it would be really a nightmare to build those kind of robots from scratch. So what ROS offers us is a framework. Using that framework, we can use that framework and build such complex robots. So for example, I am about to build a robot which I want to navigate autonomously in my room. So what all things does it involve? It involves controlling the motors, it involves path planning, it involves LiDAR, it involves camera, it involves various other things, mathematical calculations. If you were to do everything from scratch, it would be really difficult thing to do. So what ROS offers us is it offers us libraries and tools which we can put together to build such complex robots. So basically ROS is a framework on top of which we build such robots. Consider it as Legos. The building blocks which we use, it offers us different blocks, and using that blocks we build a building. So again, same is with ROS. And why do we use ROS2? So again, as Mohammad Amar mentioned, that it is an industry standard. Wherever you go, they require that you should know ROS2, and even NASA and Boston Dynamics and all these great firms also use ROS2. So before that, I would like to share with you guys the main thing why should we use ROS2. So ROS2 has this philosophy that don't reinvent the wheel, which means that if a group of people have put in their energy and hard work to build something, as engineers we should use that and build on top of it rather than inventing everything from scratch. So this is one more reason why to use ROS2. So we will move forward. So since now we know what is ROS2, now we will see how to set up ROS2 in our systems. So to set up ROS2 in our systems, mm, we will go to here. You just go to Google and type ROS2 humble documentation. Here you will get ROS2. So in our case, we were using ROS2 humble. If you are using Jazzy, you can type ROS2 Jazzy documentation. So here we are at the ROS2 humble documentation. Here you can go to the installation part. Once you click on the installation part, you will see Ubuntu Debian packages. Just click on that. So it's fairly simple to install ROS2. The only thing is that you should have a working Ubuntu environment, either 22.04 or 24.04. So Humble will work on 22. So here we have to just follow the steps to install ROS2. So I'll just put it this side. I'll open a terminal. I'm just sharing as to how to install. I won't be doing it because I already had this setup. So here are the steps. So first step is set locale. Okay, so you just go here and here you can see the copy icon. You just click on it and here in the terminal, you just paste it. To paste it on the terminal, use command Control Shift V. Once I put Control Shift V, everything is pasted and then I press enter. Once I press enter, few things will start running in the background and you wait till everything is completed. Once everything is completed, you go to the second command, setup sources. Again, you go here, copy this and paste it in the terminal, Control Shift V. Again, you press enter. Things will start happening, installations. You wait. Once everything is done, Once everything is done, you go here again, then copy the second command, this one. Again, you paste it here, wait for the installations. Then you go here, sudo apt update, copy, paste. Once it is done, then you do sudo apt upgrade, copy, paste. Once that is done, then you select this version. This is important. You select this version, sudo apt install ROS humble desktop. Just let me increase the size. Yeah. So you select, after everything is done, you just copy this command, sudo apt install ROS humble desktop, copy this, paste it here. So this is a big file. It will take time to download. You just have to wait. Once it is downloaded and installed, then you don't copy paste this command because this command is the one without the graphical user interface. So you leave this command. After sudo apt install ROS humble desktop, you directly copy this command, sudo apt install ROS dev tools. You just copy it from here, paste it here. Once you have done all these things, ROS will successfully get installed on your system. Okay. So once ROS is installed on your system, you have to copy this command, source opt ROS humble setup.bash, and paste it here. So what it will do is it will source the environment. So this was about the installation of ROS. Since I already have installed on my system, so I won't go into it, but these are the steps and you just have to copy paste it. It will get installed. So now let's see what is sourcing. What do we mean by sourcing? So what is sourcing? So when we install ROS, our system doesn't know about it. It doesn't know if something known as ROS2 exists on a system. To sell the Ubuntu system that there is something known as ROS2, we have to source it. So we have to use this command opt ROS humble setup.bash, and what it will do, it will tell the system that the ROS is installed on the machine, your local system. So to source this, every time before opening the terminal, you'll have to run this command source install setup.bash. So it will tell the system as to ROS is there. But we don't want to run it every time whenever we open the terminal. So to avoid this running this command every time, what we will do is we will just copy this from here only. We will copy this source and we will type this gedit dot bash rc. Okay, this is the command which we will type gedit dot bash rc. We will press enter. Once we will press enter, this file will get opened, and the sourcing command which you had copied, you just go to the end of the file. This is the top of the file. You just scroll down to the end of the file. Your file should end somewhere here. Okay, after the last line in your file, you just paste that command source opt ROS humble setup.bash. I have just pasted it here. You have to do the same. Once you paste this command here and press save and leave this, so what will happen is whenever you open a new terminal, every time ROS will get sourced automatically. You don't have to paste this command or run this command every time. It will happen at the backend. So how is this happening that it is getting sourced every time on its own? So for that, we will have to see what is bash rc exactly. So what is bash RC? Whenever I open a new terminal, for example, I open a new terminal here. I just opened a new terminal here. So okay. So whenever I open a new terminal at the backend, a script runs on its own. A piece of program runs on its own whenever I open a new terminal, and that piece of program is bash RC. This script at the backend runs whenever I open a new terminal, and whatever I put in this script, whatever commands, that will also run, and it will get sourced automatically. So we will also be putting one more command in the bash rc file when we will be creating our own ROS2 workspace. So to run ROS, you have to keep two things in mind. As a beginner, like we tend to forget it. Every time you run ROS, you have to source the environment, and every time you run a script, you have to source the workspace, which we will be looking forward. To source the environment, you don't have to do it every time. Just paste this command in the bash rc script. Whenever you open a new terminal, ROS will be sourced. Okay. So let's till now, if you guys have any doubt, you can just unmute and ask. For us to do, we need to use VM, or is it okay to do it in WSL? As long as it is working, it's fine. But when we go into advanced sections like running opening gazebo rviz, then you might get some issues with WSL, even VM as well. So if you are seriously into robotics, I would suggest to dual boot your system, one with Windows and other with Ubuntu. That would be a good way to go. Any more doubts? If you guys have, you can ask. Yes, you can ask, unmute and ask. Difference between humble and jazzy. So like humble is the previous version, jazzy is the recent version of ROS2, and the most recent version is kaiju kilted. So but majority of the people are working on humble only. There is no such difference as such. There are only few commands in the gazebo or in the controllers part that are different. So you will not face any issue with using humble and jazzy. They are almost the same, just different versions. Then I think you guys are clear with what is sourcing and how to go about with ROS2, what is bash rc, and how to place your commands inside the bash rc file. So assuming you guys are clear with it, we will move forward. So yeah, so here we have taken a first step, and I have successfully installed ROS2, and now we know what is bash rc, and now we are ready to dive deep. Okay, so now we will start covering these things. So we will cover nodes, topics, messages, services, and the command line tools. So we will not directly jump into how to write our first node or how to program it using Python. First, we will look at the most basic commands which are required to like get friendly with ROS2. So these are the few commands which are listed here. I'll be explaining each of them with the help of projects in detail. So let's move forward. So let me introduce you guys with Turtlesim. So what is exactly Turtlesim? So Turtlesim is like whenever you are starting ROS, so the first thing as a beginner you do is Turtlesim. So it's kind of a hello world. Whenever you learn to program, the first thing you print is hello world. So in ROS, Turtlesim is kind of a hello world kind of a thing. So this is the command to install Turtlesim: sudo apt install ROS humble Turtlesim. I'll just copy this command and I will paste it here. You just have to paste it, Control Shift V. Again, I have installed it, so I am not installing, but for you guys who don't have Turtlesim, you can use this command to install Turtlesim. Command for Jazzy will be same. You just have to replace humble with Jazzy. ROS Jazzy Turtlesim. Okay, the command will be same. So you can install Turtlesim like this. So I have Turtlesim installed. So I'll just run this command, ROS to run Turtlesim node. So let's see what is Turtlesim exactly. I'll just paste it. So what are we doing here? We are running, what is this? Turtlesim is the package in which the Turtlesim node is present. We will be looking at it as we move ahead. You'll get a clear understanding of it. Right now I'm just running it. If I press enter, this blue screen with a cute turtle in the center will open. So this is a Turtlesim simulator and it helps us understand the concepts of ROS2 very intuitively. Uh, you'll see whenever you run commands, you'll see visually as to what is happening at the backend. So using this, we can learn ROS in a very intuitive way. So this is what we refer to as Turtlesim, and using this, we will understand the concepts as we move ahead. So let's see our first thing. What are ROS2 nodes exactly? Okay, so let me explain it visually. So we will see what are ROS2 nodes. So, so for example, let's say I am building a robot. So let's consider this box as a robot that we are building. So let's say it is an AMR. It is an autonomous mobile robot, the one which I showed you guys at the beginning. Okay. So what all things will it have? It will have a controller section, which from which the motors will be getting controlled. It will have a sensor section from which the bot will be getting all its data. It will have a processing section wherein all the data will come and the bot will process it. So for example, these are the sections available. So for example, there are many sections, but these are the sections available. So this is the entire robot. These are what we refer to as packages. Okay. So I'll create one package which is entirely dedicated to my sensors. In my bot, for example, I will be using LiDAR sensor. I will be using ultrasonic sensor. I will be using, for example, a mic. I will be using a camera sensor. Okay. So these sensors are there. So I will create a ROS2 package which will contain scripts or programs for all these sensors individually. So a program that is only controlling LiDAR, a block of program which I have specifically written to control or get data from the LiDAR sensor, I call that as node. So nodes are nothing but scripts or block of programs which are supposed to perform a specific task. Okay. So if I write a node or a program to capture sensor data from the LiDAR sensor, so it will only capture data. Its work is only to capture data for the LiDAR sensor. So that is a node. Again, I can write a program to capture data using ultrasonic sensor. So it will not capture data from LiDAR. It will only capture from ultrasonic. So again, that's a node. So I have multiple nodes inside a package. Camera node. Again, for motors, I'll have a motor control node. It will control the motors. I'll have a encoder node. For example, it is capturing data from my encoder and giving it to me. In the processing section, I will have, for example, say I will have a PID node which is doing all the PID calculations at the backend. So basically, node is a block of program. For example, this is a node. So node is nothing but a block of program which performs only a specific task. This is node, nothing else. It's just a piece of program that performs a specific task. So this was about nodes. So we will see here as well. So robots are complex, as we all know. So what nodes do is it breaks the entire complexity into manageable pieces, small manageable pieces. If I write the entire, for example, if I write this entire thing, if I write in one program only, that one program is responsible for controlling motor, one program is only responsible for capturing data from camera, one program is only responsible for capturing LiDAR, everything is in the same program. It will be very complex to write such code and more complex to debug. So what nodes give us that, for example, if my camera sensor, if my camera sensor fails to operate, so since I have written the camera node separately, only the camera thing will stop working. Rest everything will be intact and working. Motors will be working, sensors will be working. But if I write everything in the same program, one error and the entire robot will stop working. So this is the flexibility which ROS2 provides us, that we can break the entire system into small chunks and those chunks interact with each other. So by this we can build a very modular system, and we can build it at scale. So this was about nodes. So we have a camera node, controller node, actuator node. So basically it's breaking down programs of the robot and making it more specific as to one program does only one thing, and that program communicates with the other program with something known as topics, which we will be covering further. So till now, if you guys have any doubt in understanding what are nodes, just unmute and ask. Which microcontroller is ROS compatible with, like Arduino or Raspberry Pi, which is the best? Are nodes similar to functions? Nodes are not functions per se. You can write functions in your own, like you can write functions in the node itself. So node is basically a piece of program which is responsible for performing a specific task. For example, I want to capture image from a camera. Now for capturing image, you can write one function in the node itself that capture image. Then you can write another function to convert that image to grayscale. Then you can write another function to detect objects in the image. You can apply edge detector, anything. So that all those things comes in one node which is responsible for managing the camera. Okay, so this was about nodes, and about the previous question, that which microcontroller is ROS compatible with. So basically, if you want to run ROS, you need a not a microcontroller but a microprocessor or a system on chip like Raspberry Pi. So to run ROS on microcontroller, there is something known as micro ROS. So that is out of this bootcamp session. So you can run ROS on your laptop or PC or Raspberry Pi. You cannot run it directly on ESP32. You have to run micro ROS on ESP32. So we will not be going into micro ROS because most of you guys are beginners, and we will cover it some other time. Okay, so this was about nodes. Uh, yes, you can use STM32 as well, but I'm not sure MicroROS will run on it or not. Okay, so this was about nodes. Now let's see using the command line as to what are nodes and how to interact with it. So the first node we looked at was the Turtlesim node itself. So when I do ROS to run Turtlesim. So this Turtlesim is the package which I showed. I made a box, and in that I made many other small boxes. So that small boxes were packaged, and inside that package many nodes are written. So ROS to run Turtlesim. So from Turtlesim package, I want to run the Turtlesim node. When I press enter, this is a node. For example, this is a node which is running for Turtlesim. Okay, and that node is responsible for this graphical user interface. So let's begin with the commands. So the first and most important command which all of you guys need to know is ROS to node list. You can write it down somewhere, or I'll share the PPT as well. So no worries for that. So ROS to node list. So what this command will do is it will list down all the nodes which are running at the backend. If I press enter, so it listed that only one node is running at the backend, which is the Turtlesim node. Okay. So this was the first command, ROS to node list. If there are multiple nodes running, for example, I am running a very complex robot, so multiple nodes will get listed, uh, like all the nodes which are running. So this lists down all the running nodes. Now the other command we will look at is ROS to node info. This will give us about information about the node. So which node we want information about? We want information about the Turtlesim node. Okay, if I press enter, so this is the information that it gave me. So we will be looking at each and everything as we move ahead, but this is the information which it gives us. Most of you guys will not understand what is it right now, but as we move ahead you guys will understand. So first it is telling that this is the Turtlesim node. In it there are subscribers, there are publishers, there are service servers, there are service clients, but it doesn't have any. There are action servers and action clients. This is the basic information about the node which it is giving us. So we will be looking at what are subscribers, publishers, service servers, and service clients. Okay, but yeah, so for now we will just keep it as, if we want information about the node, we use this command ROS to node info, then the node name which we want information about. We will come to this command once we understand what are publishers, subscribers, and topics and all those things. Okay, so these were the two most important commands related to the node itself. So we have one is ROS to node list. It will show you all the running nodes, and then the other info one will show you a detailed report of the node which you want to get a report about. Okay, so we will move to the next thing, which is topics. So we will see what are ROS2 topics. So again, this is a very important concept as to what are ROS2 topics. So for example, I have a node here and I have another node here. We call this node as node 1, N1, and we call this node as node 2, N2. And there is something known as a topic in between. So how does this node, which for example is responsible for capturing the camera data, this node is okay. This node is responsible for capturing the camera data, and this node is responsible for processing the camera data. This node is responsible for processing the camera data. So how do these nodes communicate? So these nodes communicate by something known as topic. So this node captures the camera data and publishes it, to this topic. And this node subscribes from this topic. So this is a subscriber. So this is the basic concept behind ROS2 topics. So there is one node which we call as publisher. What it does is it does what it has to do, and then it publishes the data to the topic, which is the middleman between communication of two nodes, and then other node subscribes the data from the topic. So this is basically it. So why can't we just directly connect these nodes? So again, this is why ROS is very modular. So if we directly connect this node and say for say tomorrow we want to, instead of, like for example, here we are using a certain processing logic, but if we want to change that logic or we want to put a different logic, we'll have to again disconnect it and then place another logic here and then connect it back again. But if we use something known as topic, it is not directly connected. It is acting as a middleman, and we can just replace this block from here, and we can add another block. So it makes things very modular. um so the only thing you need to know when using topics is that nodes topics communicate with the nodes using something known as interface types, which is nothing but the language that the topic understands. We will see as to what it is in detail, but you just have to remember 2 3 points regarding topics. First, nodes communicate with each other via something known as topics. Why do we use topics? It makes things modular. Right now this node is communicating with this node, but I don't want this node 1 to communicate with 2, rather I want to communicate it with 3. So if I want to communicate it with 3, then I'll have to break this connection and connect this here. So to avoid that, I'll just replace 2 and I'll just add 3 here, n3. Okay, so you just have to, it's what do you call it? It's like a block kind of a thing. You just remove one block and add another block. So it provides modularity. Other thing you need to remember is that N1 is not aware about N2 or say N3. N1 is just aware that it's publishing its data to this topic. For example, this topic name is image. So N1 is only aware that node 1 is only aware that it is publishing its data to the image topic. It doesn't know which node is subscribing from the image topic. Its job is to keep on publishing this stream of data continuously. And N2 is not aware about N1. It only knows that I need to get data from the image topic and I'm continuously getting the data from the image topic. It need not be concerned about what N1 is doing. So again, this is very modular. Tomorrow I can just replace N1 with N3 or N4, anything, and it need not know about N1. So this is 2 things you need to know about topics. And the third one is that the only thing which you have to keep in mind when dealing with topics is that topics communicate with each other in a certain fixed language, which we call as message type or interface type. Okay, so the only thing a node needs to know when communicating it with a topic is that it speaks the same language which the topic understands. For example, this is node 1, this is our topic, and this is node 2. Okay, node 1 is sending data in the form of integer. Okay, and the topic, and node 2 wants to subscribe data in the form of string. Then this will not happen. So it is very important that the topic is predefined. That is, the topic is of integer type, or topics accepts data only when the data is of integer type. So then node 1 will send integer type data, and 2 also has to subscribe integer type data. If 2 has to subscribe string type data, then you build another topic which is of string type and then publish to that. So these are the few things related to topics. And the most important thing is that topic understands only a specific language. Both the publisher node and the subscriber node need to communicate in the same language. Then only the communication will get established. To explain it more clearly, so here you can see on the PPT that topic is a communication channel between nodes. One node publishes data, another node subscribes data. Topics is unidirectional. The important thing about topics is it is unidirectional. When it cannot go like this. Or for example, N1 publishes data to a topic. Okay, so it is not that topic will send a reply, okay, I have received the data. It's not like that. It's a continuous stream of data. N1 continuously keeps on publishing to the topic, irrespective of someone is subscribing or not. It keeps on publishing. For example, N2, we run N2, then N2 subscribes from this continuously. So it is unidirectional communication. It's not bidirectional. Okay. And so again, this is a one-way stream of data. And what are messages? I just showed you the language in which this node is interacting with the topic. These are known as messages. We will look it in detail and when we go in command line. So messages are the actual data sent on the topic using the language. Okay. So messages can be of different type, int, float, string, or a combination of all. So those are messages, and you must keep in mind that the message type both for publisher and subscriber should be same, should match the message type of the topic. For example, topic is made in such a way that it accepts only character type data, so you cannot publish string to it or subscribe integer from it. You have to publish character, subscribe character. Let's understand it in a better way. um, let's see in the command line. So we will see now what are topics basically. So here, let's see what are topics. Let me clear this. And now few commands which are very important for topics is that, okay, till now, if you have any doubt as to what are topics in the theory, you can ask. And also,
Mhm. Actually, I'm a little bit confused about that. Node is, for example, node is getting data from the camera, and I'm doing something calculations, etc. And then I want to send the data to the certain topic through message. Okay, done. So node is publishing a data on the topic. Then publisher is something different. We have to write a certain another type of code to publish it, or publishing is in the node, is doing in the
okay,
node.
yeah. So when we will move to the code section, you will understand it very clearly. But right now, to explain in short, there is one node which we call as publisher node. That node's task is to do what it is doing and like capture data from the camera, for example, and it need that publisher node publishes the data captured to the topic. Say the topic name is image. Okay. And the other node which has to do the processing, it that node we call it as the subscriber node, which is subscribing from the topic. So one is publishing to the topic, we call that publisher node. Node and publisher, they're not different things, but if a node is publishing to a topic or sending data to the topic, we call it publisher node. If a node is accepting data from a topic, we call it subscriber node. We will get to see it clearly as I explain in here. uh, okay. Can two nodes have multiple topics between them? Yes. For example, if a node is publishing to image topic, multiple nodes can subscribe from the image topic. That is not an issue. Can a topic convert the data type? No. Topic cannot convert anything. Topic is just a middleman. It just relays the information from this node to that node without actually connecting the two nodes. Think of it like this. Um,
If one node is publishing the data to the one topic, so only one node can publish to one topic, or
No, no,
multiple
no.
nodes can publish to.
Multiple nodes can publish to a topic and multiple nodes can subscribe from the same topic. Just that you have to keep the message type same. If the topic is of string type, you multiple nodes, every node has to publish the string type data only.
Yeah.
Same for the
Okay,
subscriber.
but it should be unidirectional.
It is unidirectional. By design, it is unidirectional. It not should be, it is. That is how it works in ROS for topics.
Okay.
We'll look at something known as services, which are bidirectional. Topic does not
Okay.
work like a feedback system. No, topic doesn't work like a feedback system. It's just a relay, just captures information from here and sends it there. Can there be multiple? Yes, there can be multiple subscribers. Can anyone publish message to topic, image as well as video? Yeah, again, as long as the format is same. So basically a video is nothing but a series of images published at a certain frame rate. For example, if a video is 30 frames per second, then it is publishing 30 images per second. So that is a video. It is nothing but an image. If a node has to send multiple type of data, do we use different topics? Yes. For different data, you use different topics. We will look at it here. So right now, one node is running at the backend, which is Turtlesim node. Now that node, let's see what are the topics present. So ROS2 topic list. If I do this, you will see that leave these two. These two are command line topics. These are the topics which are there for Turtlesim node. So you can see there is this topic Turtle1 command velocity, Turtle1 color sensor, Turtle2 pose. So basically the topic is this. Turtle1 is just a namespace. This is the name of this turtle. Tomorrow if we spawn or generate two turtles here or three turtles here, then it will come as Turtle1 command velocity, Turtle2 command velocity, so on. So these are topics. Let's see what's happening at the backend. For that, okay, let's first try to move the turtle. So what I will do now? So to move the turtle, I know my Turtlesim node is running. First point is done. I ran my Turtlesim node. Then I did what are the topics available which I can use. So I did ROS2 topic list. So I found out that these topics are available through which I can communicate to this node. So how do I use this topic? So as I mentioned, to use a topic, you need to know the language that the topic understands. How do we know the language? Another important command. ROS2 interface show. Interface is the language which we are referring. Of which topic do we want to see the, okay. First of all, we don't know the interface itself. So we will have to see the interface of the topic. So for that, we do ROS2 topic info, and I want to see information about Turtle1 command velocity topic. So command velocity is nothing but the topic responsible for sending the commands. Like to the command velocity topic, we will be sending the commands, velocity commands to move the turtle. So what we will be doing is using this terminal on which I am hovering my mouse, using this terminal, we will be sending velocity commands to this topic. And from this topic, this node is subscribing. So I will use my terminal, send data to this topic. This topic will receive the data, and from this topic, this node will subscribe the data, and the turtle will start moving. So for that, we need to know the language that this topic understands. So for that, we use this command ROS to topic info. We want to know the language of this topic specifically, as different topics have different languages. If I press enter, you will see that the language this topic understands is geometry messages message twist. Now again, what is this? So this is the specific interface type. So for now, okay, let's see what is inside this. Okay, initially I told that there are integers, float, string, character. So let's see what's inside this. So to see what's inside this, we do ROS2 interface. This is nothing but the interface or the language the topic understands, specifically this topic. ROS2 interface show. I want to see what's inside geometry messages. In the twist message, I want to see what's inside it. Now, if I press enter, you can see this, that inside this, there is nothing but this. It has total six variables of type float64. The float64 is a very primitive data structure used for storing decimal numbers, and 64 is nothing but the size of it, 64 bits. So this interface or this message type contains this inside it. It contains linear xyz and angular xyz. So what does it mean? So if I want to move my turtle, I have to give it velocity to move. Again, let me explain here. For example, this is my turtle. Okay, this is my turtle. If I want my turtle to move forward, I will have to give it a velocity in the forward direction. And if I want my turtle to rotate, I have to give it an angular velocity so that it rotates and becomes like this. Okay, so there is something known as two things. There is something known as holonomic drive. Again, this is like not required as such, but I'm just giving this for explanation. Holonomic drive, and there is something known as non-holonomic drive. Okay, so what is holonomic drive? For example, for let's see what is non-holonomic drive first. We all drive a two-wheeler, four-wheeler, which is a car, let's say. So in this car can only move forward. Here is the steering wheel, for example. This is the forward direction. So my car can only move forward, and my car can only rotate about the z-axis. Say for example, this my pen is coming out of the screen. So this is the z-axis. This dot is coming out of the screen. Okay, so my car can only rotate about this axis, and my car can only move forward. So using this, I can steer my car, I can move forward and at the same time rotate. So my car will go like this, my car will go like this. Okay, but my car cannot move like this. It cannot just slide sideways. Either it can move forward, and when I turn the steering wheel about the z axis, about this axis, it turns, it makes a turn. So this is non-holonomic drive. Drives that can only move forward in the x direction or can turn about the z axis. Okay, this is my car. It can move only forward in the z x axis and turn about this z axis. This is non-holonomic drive. Drives like you might have heard about drives, wheels like omni wheels, mechanism wheels, or swivel drive. In certain robots, you can see that that robot can move forward also, and it can slide sideways also, and it can take rotate about z axis as well. So these are holonomic drives. So these can move in x also, in y also, and rotate about z. Okay, so the turtle So the turtle which we are using here, it can only move forward like this, and it can only rotate like this. It cannot move sideways. So for that, we will be using only linear x variable, to which we will be publishing the linear velocity in meters per second. We will be publishing linear velocity in meters per second so that our turtle moves forward like this. And since our turtle is non-holonomic drive, it cannot move sideways. We will not be using y. And I want to rotate my turtle like this. So I will be using angular z. We will be publishing angular velocity about the z axis in radians per second to rotate our turtle. So let's see how to do that. So basically you have understood that we are using this command line to publish command velocity commands to this topic, and this from this topic this node is subscribing data and it will move to this topic. We have to publish using this message type, geometry message twist. What is inside geometry message twist? There are these variables inside, out of which we are concerned only about linear x and angular z. Let's try to move our turtle forward first. So to publish data to topic, we use this command, ROS to topic pub. ROS to topic pub. To which topic do I want to publish data? I want to publish to turtle1 command velocity topic. And what is the language that my topic understands? It understands geometry message twist language. And what was there inside geometry message switch language? There was linear XYZ and angular XYZ. For example, right now I want my turtle to rotate about the Z axis. So let me just publish a angular velocity command of 2 radians per second. So you will see that the turtle will start rotating about its own axis. If I press enter, now you can see that the turtle is rotating about its own axis. This terminal is publishing commands. Let me show what is happening at the backend. So to see what's happening at the backend, we use a tool known as RQT Graph. So it shows everything visually as to what is happening at the backend. If I press enter, you can see this. You can see this graph has opened here. Now see what's happening. This rectangle is the Turtle1 node, the Turtlesim node, or the Turtle1 namespace. Okay, and in it has the Turtle1 command velocity topic, and this is the Turtlesim node, the blue box. The ROS to CLI, this terminal on which I am hovering my mouse, which is publishing the data, we are using this terminal to publish velocity commands to this topic. So this has become a publisher now. It is publishing to this topic, and the Turtlesim node is subscribing from that topic and moving the turtle. Okay, so now for example, I don't want to move my turtle like this. I not only want to rotate my turtle, but also I want to move it forward. So if I give my turtle a forward velocity of 1 meters per second, so now what will happen? My turtle will start moving forward in x-axis, and at the same time it will be rotating about the z-axis. So it will make a circle. If I press enter, you will see that my turtle is making a circle. It is moving forward in x and rotating about z. To make a bigger circle, let's just reduce this. Now you will see that my turtle is making a bigger circle. So what's happening? Like how suddenly my turtle is making a bigger circle? So initially, my turtle was rotating at a velocity of 2 radians per second. So every second it is rotating 2 radians about its axis, and it was moving forward with 1 meters per second. But now when I reduced the angular velocity to 1 radians per second, it is not rotating about its axis that quickly. So the radius of curvature has increased. So it is taking a long time to turn. Just like in your cars, when you turn the steering wheel to the extreme, it takes turn in very less space, in making a very less radius. But when you have to take a very long turn, then you don't turn it to that extreme. It's just like that. What is the command to make turtle rotate again? Okay. So till now, I'll explain the command, but till now, have you guys gotten an idea about basic idea about what are topics and what are nodes? If you haven't, then just unmute. Everyone is clear about what are topics? If anyone has doubt, just unmute. I'll explain. Can you tell again what is node 1 here? Okay. So node 1 here, let me once again explain here. So what's happening here is I am using my terminal or the command line interface, the black screen on which I am writing the commands. I am using my terminal as node 1. It is publishing velocity commands. It is publishing velocity commands to the command well topic. Okay. And I have my other node N2, which is the Turtlesim screen itself, which is subscribing from this topic. So what I did was I did ROS to topic publish, and then I wrote the message type, and then I wrote the values I want to publish. So this terminal, what it did was it started publishing those values to this velocity topic, and from this topic, this Turtlesim node is subscribing data into and moving the turtle. So this is how topics work basically. Just that, just that you need to know the message type. So in our case, the message type is geometry, geometry messages, message twist. So we are publishing twist message. So that whenever, like, when you move ahead with robots and all those things, whenever we want to publish velocity commands to any robot, we use only two types of messages: twist and twist stamped. The twist stamp, we will not look at it. It's just that it is twist, but with timestamp as well. So and what's inside the twist message? Twist message has linear XYZ, angular XYZ. How did I know that? I know that using this command, ROS to interface show geometry message twist. Where if a node has to send multiple type of data, do we use different topic? Yes. What is the command to make turtle rotate again? So to make the turtle rotate, you just have to publish. This is the command to make the turtle rotate. You are using ROS to topic publish. You are publishing to this topic with the message type. And here you only publish the angular Z, you don't publish linear. So turtle will rotate on spot. Where did we exactly mention about publishing and subscribe to topic in our case? So again, we are clearly mentioning using this keyword pub, we are clearly mentioning that act as a publisher and publish to this topic with this message type. This is the data. And in the Turtlesim node, the code which is at the backend, it knows that there we have done, whoever has developed it has done the programming that it has to subscribe from this topic only with this message type. So we did reverse engineering. How we did that? We first did ROS to node list. You should manually type those XYZ or it is inbuilt. So these are inbuilt. You don't have to manually type it, but you can create your own message type as well. So what reverse engineering we did, I'll just explain it quickly, then we will move forward. What reverse engineering we did, we first ran the Turtlesim node using ROS to node list. Then we got to see that okay, Turtlesim node is available. Then we did ROS to topic list. We did ROS to topic list. We saw that okay, command velocity topic is available with other topics as well. But I know that to move the turtle, I have to publish velocity commands to this topic. Okay. So now I don't know what to publish and what is the message type it understands. So again, I did reverse engineering and I found out that using ROS to topic info, and then here I put command velocity topic. It is turtle1 command velocity. I am just writing command velocity. So by this, I got the type of the topic, the topic type, interface type I got as geometry messages and twist message I got. Then I don't know what is inside twist message. So I did ROS to interface show and I copy pasted this entire type here. Okay, then it showed me that okay, inside this I have linear XYZ and angular XYZ velocities. Since our turtle cannot move sideways, it can only move forward in X and rotate about Z. So we are using linear X and angular Z to publish velocity commands to turtle. The Turtlesim node is subscribing via the command velocity topic and moving the turtle here, not here, but wherever the Turtlesim node is running, say here. So this was the entire pipeline as to how things are happening. If still it is not clear, you can just unmute and ask, can we change it to holonomic drive? You can try and see how it works. I haven't tried, but generally we do X, like X and angular Z only. Okay, so it is clear till now here, everything. Okay, then we have covered what are topics, what are messages. We have covered this command ROS to topic list. We have covered the information, ROS to topic info. Let's I guess I haven't we haven't okay, let's do one thing. Let's cover ROS to topic info, and let's look inside turtle1 command velocity topic. If I press enter, now you can see publisher count is 0. That is, no one is publishing to this topic now. But subscription count is 1. Why? Because this Turtlesim node is continuously subscribing data from this topic. However, no one is publishing data to this topic right now, so the turtle is not moving. But yes, you can give as x as negative. It will start moving back. So now if I do ROS to topic pub and I want to publish to turtle1 command velocity with message type geometry message twist, and inside data is this. Let's give this time as -1 only, negative value. Now our turtle will start moving back. So right now, see, you can see publisher count is 1. But here, as I start this, the publisher count will become 1, because then this terminal will start publishing to this topic and this node is already subscribing. If I press enter, you will see that our turtle is moving back. And if I run the same command, now publisher count has become 1, because this node is publishing to this topic and this Turtlesim is subscribing from this topic. Clear? Okay. So as we move ahead, we will explore the different topics as well. So you'll get to know about other topics. So we have seen what are ROS topics, topic list, topic info, interface show saw. We have covered this command, the topic publish command. Let's see what is happening inside the topic. So here you will understand topics even more clearly. In this terminal, we have our Turtlesim node running, but our turtle has collided. So let's run it again. So ROS to run Turtlesim node. Here our turtle has started. Now, let me publish again to this and make a circle. So ROS to topic publish. Want to publish to turtle1 command velocity, and the message type is geometry message twist, and data inside is linear. I give an angular velocity of say 1, and this time I want to make a bigger circle, so let's give linear velocity as say 3. Okay, so linear velocity in meters per second, angular in radians per second. If I press enter, turtle will, okay, I guess it is making a very big circle. So it is colliding. No, right now it's not colliding. Okay, so our turtle is moving. Now, let's see what is happening inside the topic. So, using this terminal, I am publishing to command well topic. Let's see what is happening inside command well. So, ROS to topic echo. We use this keyword ROS to topic echo to see inside the topic as to what is happening. So, ROS to topic echo, I want to see inside turtle1 command well topic. If I press enter, you will see this, that this node is publishing x as 3 and z as 1 to the command velocity topic, and here we can see that we are successfully receiving this data. So this is what ROS to topic echo does. You can, using ROS to topic echo, you can see inside the topic as to if it is mostly like a debugging thing, like if things are working fine or not. For example, let me see what's inside this topic, or let me show one more topic. ROS to topic list, we had this topic as well, pose topic. What does pose stand for? Pose stands for position and orientation. In this turtle, we have two things. We have the position, that is currently at which coordinate the turtle is at, x coordinate and y coordinate. So this point where I am hovering my mouse right now, okay, let me explain it here quickly. So what is pose? Let me just explain it quickly. So consider this as the Turtlesim window. My turtle is here as a point object. Consider this coordinate as 0 comma 0. This point in the Turtlesim blue screen is 0 comma 0. My turtle is currently, when my turtle is stopped, this point is almost 5 comma 5. So like that, this point will be almost 10 comma 10. However, it is 11, but for simplicity we are keeping 10. It will not be 10 comma 10. It will be 10 comma 0 because y is 0. This point will be 10 comma 10, and this point will be 0 comma 10. I hope that you guys are familiar with basic coordinate geometry. So what is pose? So pose is nothing but position and orientation. That is current position of my turtle, which is x comma y. Where is my turtle currently? And what is the orientation of my turtle? My turtle is facing like this, or my turtle is facing upwards. What is the orientation? So that is theta, the orientation. Again, this is in meters and this is in radians. This is the pose topic. So this is what the pose topic does. It gives you the current position and orientation of the turtle. For example, let me just spawn the turtle once again and let's see what's happening inside the pose topic. So if I do ROS to topic echo and I do turtle1 pose, let's see what's happening inside the pose topic. If I press enter, you will see this. That the post topic, it is telling that my turtle is currently at 5.5, which is this, which I showed you, and the turtle is currently at theta. So we are considering the x-axis as reference, and my turtle is parallel to the x-axis. So the theta is 0, and turtle is not moving, so linear velocity is 0, angular velocity is 0. This is what is happening inside the pose topic. Again, how will I know what is inside the pose topic? So for that, I will do ROS to topic info. I want to see the interface type of pose topic. If I press enter, we will see that the interface type of pose topic is Turtlesim. From the messages package, it understands pose message. Unlike command velocity, it only understood twist message, but this is different. So you can see that every topic has a different message type. It need not be that every topic has same message type. This understands a different message. If I communicate it using command velocity message, twist message, it will not understand. Same for command velocity. So let's see what is inside this. So again, to see that, we will do ROS to interface show. I want to see inside Turtlesim message. I want to see what's there inside pose message. If I press enter, you can see pose message has these things. Command velocity had linear xyz, angular xyz, but pose message has this float 32x, that is x coordinate of the robot where it is right now, y coordinate, theta the orientation, so this covers the position and orientation, and the linear velocity, that is the linear x at which my turtle is moving, and the angular velocity, that is the angular z with which my turtle is moving. So this is in meters per second, this is in radians per second. So this is inside, this is what that is inside the pose topic. And if now I just now showed you the pose of the turtle when it is not moving. Velocity is 0, pose is 5 comma 5, and theta is 0 because it is parallel to x-axis. Now let me move the turtle. So ROS to topic pub, I want to publish to turtle1 command velocity topic. Interface type is geometry message. Inside that is linear. And for example, let me just rotate my turtle. My turtle is rotating. Now let's see what is happening inside the post topic. So how to see inside the post topic? So ROS to topic echo turtle1 post topic. If I press enter, now you will see that since my turtle is only rotating, so only the orientation of it is continuously changing. The x and y coordinates is not changing. The turtle is at the point, and linear velocity is not changing since the turtle is not moving forward. Only angular velocity is changing, which I gave as 1 radians per second. For example, now I stopped the turtle. So this is the last thing where it stopped. Linear is 0, angular is 0, theta is this. I stopped. Now let me move my turtle forward as well. To move my turtle forward, I will give a velocity of 1 meters per second. Now if I press enter, you can clearly see that now x and y are also changing, because at every point my x coordinate and y coordinate of turtle are changing. At the same time, my theta is also changing. My linear velocity I have given as 1, and my angular velocity also I have given as 1 radians per second. So this is a closed loop system, which is very important in robotics. That how will I know that I am giving 1 meters per second velocity to my turtle and my turtle is actually moving at 1 meters per second or not? So is this right? So we only create nodes, not topics. Meaning that if I create a node that publish integer and publish to a topic, so topic will have an integer type. Yes. Is it right? Yes, you are right. And you can create your topics as well, your own topics, which we will be seeing in the program. Right now, since the Turtlesim is pre-programmed, so it comes with certain topics. So we are using that to clear our concepts. Once we move in the programming section, we will be writing our own nodes, creating our own topics, defining the message type also on our own. So echo acts like a subscriber. Yes, echo acts like a subscriber. So basically, this node, the most bottom node, which is publishing to the command well topic, turtle. Okay, let me show you what is happening exactly at the backend. If I just open RQT graph, you'll see it more visually. RQT graph. If I press enter, now you can clearly see what is happening. One command line, one CLI is publishing command velocity to the Turtle1 command velocity topic. That is this one on which I'm hovering my mouse cursor. This CLI, this terminal is publishing velocity commands to Turtle1 command velocity topic. This Turtlesim node is subscribing from this topic and moving the turtle. Now the Turtlesim node is publishing to Turtle1 post topic the current coordinates of the turtle. It is publishing, and using the echo command, or another CLI, another terminal, which is this terminal, is subscribing. So this is a closed loop system. One terminal is publishing command velocity, Turtlesim is subscribing command velocity, then Turtlesim is publishing the current position and orientation of turtle to Turtle1 post topic. And from the Turtle1 post topic, another terminal is subscribing the pose and printing it here. You can see like this it is going. This is what is happening at the backend. So till now, if you guys have any doubt, just let me know. Is it clear to everyone? Okay, so what is the core philosophy of ROS2? Core philosophy of ROS2 is don't reinvent the wheel. Someone has written build everything from scratch, so that is not the right answer. That's what we are using ROS2. We don't want to build everything from scratch. We want to use ROS2 as a framework to build on top of it. We don't want to build everything from scratch. We don't want to reinvent the wheel. So, okay. Um, okay. Software, hardware is secondary. So the correct answer for is don't reinvent the wheel. Okay. Okay. Subscriber can be publisher. Yes, it can be. Depends on the node. Here you can clearly see that in this Turtlesim, it is acting as a subscriber. At the same time, it is also publishing. So this Turtlesim node is subscribing command velocity data from the command velocity topic. At the same time, it is publishing the pose data, position and orientation data of the turtle to the pose topic. So this node is acting as a subscriber and publisher at the same time. But it cannot act as a subscriber and publisher with the same topic. It is not that it is subscribing from a topic and it is publishing back to the same topic. Two-way communication is not possible. It is continuously subscribing from one topic, but it is publishing to some other topic with different message type or language. it cannot be possible that it is subscribing from command velocity and also publishing back to command velocity. That is not possible. If I want to develop an AMR using LiDAR sensor DC motor, Raspberry Pi, what would be the advantage and disadvantage of implement system with ROS compared to without ROS? As a beginner, you should you use ROS. Using ROS, you can quickly build the prototype. But at the same time, if you are working on a very critical project, and you want to do everything in-house, so there are many companies who don't use ROS. They build everything from scratch, just like Apple doesn't use anything from anywhere. It builds everything in-house. So you can do that, but again, depends on your competence and expertise. Okay, so I think everything is clear till now, so let's move forward. Are you guys tired? Everyone is still, no one is sleeping. Okay. uh okay then. Okay, so we have covered publisher, eco, which is subscriber. Now let's move forward. So we have also published data to our turtle, and we have used our turtle. We have moved our turtle. There you can use this keyword as well, once. So what it will do is it will publish data only once. Once the turtle will move forward, then it will stop. But we were publishing data continuously. So again, depends on the use case. Also, you can use this keyword, publish rate. Right now, by default, the publish rate is 1 hertz. That is, it publishes data um, what every 1 second. Yeah, 1 hertz is for every 1 second. But if you increase the frequency, then it will publish data more often. Like for 10 hertz, it will publish data velocity commands every 10 times, every 10 times per second. That's 10 hertz. So we were using 1 hertz by default. I want to make the turtle move in delay, like after making it move from one point to another. Move to next one. Yes, you can move the turtle in delays. That is what this command does. If you put rate as 0.1, then it will move, then stop, then move, then like that will move in jerks. Or you can do that programmatically as well. We will be seeing that as we move forward. Okay, then we have covered this as well. Now let's see what are ROS2 services quickly. Since few of you guys have to leave exactly at 5, so I'll cover this quickly, and then we will meet tomorrow. So let's see what are ROS2 services. So till now we have covered nodes. We have a clear understanding. We have covered topics. We have covered all the useful commands related to nodes and topics. We have seen that topics are unidirectional. We cannot publish data at the same time, get a response. It only publishes and other one subscribes from it. Now there are something known as services in ROS2. So what is a service? Just like in restaurants, you go, you place order, you get food. So that is a service. You place a request to the waiter or the server, you get a response. So that is basically what is service in simple terms. Everyone will be knowing it. So there are few commands related to services which we will see. Okay, so here you can see that a service is request response system, and a client node asks server node to do something, waits for confirmation and response, and it is bidirectional. How is it bidirectional? Again, how is it bidirectional? Unlike topics, this was my topic. This publisher was continuously publishing. The subscriber was continuously subscribing. There was no request response system. But this is my service. So there will be, this is my service, or call it a server. Let's call it service for now to avoid any confusion. This is my service. There is one node N1. This sends a request to the service. This service processes the request and then sends a response back. So unlike topics don't send response back. They are one-way communication. Service, you send request, you get a response. This is bidirectional communication. Okay. So this is what a service is. Just like topics had their own message types or interface or the language which in which they communicate. Similar to that, services also have their own language, the request response system, so in which they communicate. So for example, a service is meant for accepting request only as integer data. So it will not accept request as string data. It will accept request as integer, but it is supposed to respond in string, so it will respond in string. For example, I say that my number is 1. I send a request to server that if my number is 1, then print hello world. So I send a request 1, server processes it. Okay, he sent a request of 1. Let me send a response of hello world. So I sent an integer, got back a response as string. So basically, just to give you a basic example, this is what a service is. Okay, so let's see the services available and the command line tools to use. These are the few command line tools we will be using. ROS to service list, ROS to service type, ROS to interface show, ROS to service call. Okay, so let's look at them one by one quickly. Again, I'll run the Turtlesim node, for example, running the Turtlesim node. Now let's see what are the services available here. Right now, okay, at the beginning, I did ROS to node info and I did Turtlesim. So that time you guys were not able to understand, but now you guys should understand something. When I did node info, you can see there is subscribers. So you can clearly see that Turtlesim node is subscribing from Turtle1 command velocity. And the message type is geometry message twist. And you can clearly see that the Turtlesim node is publishing the post data, X, Y, and theta data to the post topic with message type this. Now you guys can understand clearly what are subscribers and publishers. And you can just respond. Okay. So now we will see what are services and what are service servers. Someone wants to, okay. Okay. So now let's see what are the services available. So to see what are the services available, we do ROS to service list. If I press enter, you will see these are the services which are available. We will be looking at these only. Clear, kill, reset, and spawn. These are the services available. We will see what each one of that does. So again, to interact with the service, we need to know the language which the service understands, the request and response framework. So to know that, we can know it in two ways. Same goes for topics as well. We can know it in two ways. Either we can do ROS to service info, and I can say I want to see inside spawn. Okay, I guess service info doesn't work here. It is service type. ROS to service type, and I want to see what's inside the spawn service. If I press enter, you will see that the spawn service understands this interface type. Turtlesim SRV stands for service. Previously, there was MSG that stood for message. This is service, and it understands the spawn service type. Also, you can do this using this command also. ROS to service list. I want to see, okay, ROS to service list. If I do -T, then you can see that the service is getting printed with the type it understands. So here you can see the clear service, it understands this type, kill understands this type, Spawn service understands this type. Everyone has their own framework. Similarly, you can do for ROS to topic list minus t. Directly, you will get that this turtle1 command velocity understands this, turtle1 color sensor this, pose this. Okay. So we will now do for service only. So for spawning is to generate a new turtle in the Turtlesim environment. So it uses this. So let's see what is inside this. Let me just copy it. Control Shift C, you copy it. And to clear the screen, you do Control L. So how will I see inside that? ROS to interface show. And I want to see inside. Control Shift V. I want to see inside this. If I press enter, you will see this, that you have to send a request. To spawn a turtle, you need three things basically. To spawn is to generate a turtle in the Turtlesim window. So you need three things. You need to tell the service as I want to generate my new turtle at X coordinate this, Y coordinate this, and what orientation I want. And you can also provide a name to the turtle if you wish, but this is optional. If you don't provide a name, it will just increment the name. Like right now we have turtle1, it will directly do name the second turtle as turtle2, turtle3, turtle4, like that. So this is the request structure. Then you are seeing this three hyphens. This is the response. This is the request framework. Then this three hyphens separates the request, and then we get this as response. That is, if I request my service that spawn a turtle at X, Y position with theta orientation, then I get a response that, okay, I have spawned the turtle with this name. Let's try to do this. So we have seen two things: ROS to service list, ROS to service type. Using the type, you get to see this, what is the type of the service. Okay. Now we will do ROS to service call. To call the service from the command line interface only. ROS to service call. Which service I want to call? I want to call the spawn service. What is the message type? My service type, my spawn service understand? It understands this Turtlesim SRV spawn. Turtlesim SRV spawn. What is inside the spawn service? Request framework. Okay. So request is this X, Y, theta, and name. So this command I am using to send request to spawn a turtle at a specific position, and orientation. So let's spawn our turtle as, so right now this is turtle1, this is at 5,5. Let's spawn it at X5 but Y 2.5. So the new turtle should spawn somewhere here. So X I'm keeping it as 5 only, almost 5, and it gets spawned almost below it, and I'm keeping this as 2. Should we copy paste XY? I'll tell that. Okay, so right now I'm spawning my turtle at X5, Y5, and theta, the orientation of my turtle, I'm keeping it as 1.57. So 1.57 is nothing but 90 degrees in radians. So right now my turtle is parallel to x-axis facing forward, but my new turtle will be perpendicular to x-axis. It will face upwards. I'm not naming the turtle anything, so by default it will get named as turtle2. If I press enter, you will see that our friend has gotten spawned here, just below it almost, because this is 5.12, I have given 5. So it is spawned at 5, 2.5 and facing upwards. This is the new turtle. And we sent a request. We made a request here, making request. You can see X, Y, theta name. We got a response. We got a response as turtle2. You can clearly see the response was this string name. So we have got a response as turtle2 has spawned. Now, if I do ROS to topic list, now what you will see? ROS to topic list. Now you will see that we have 6 topics. 3 topics for turtle1, 3 topics for turtle2. These were just namespaces to differentiate between different topics. So now if I publish command velocity to turtle1, this will move. because this turtle is subscribing from turtle1 command velocity, so this will move. If I publish command velocity to this, then this turtle will move because it is subscribing to this. Let's see. Let's try to move our turtle once. So ROS to topic pub. I want to move, say, turtle1 command velocity. Message type is geometry inside it. So someone was asking how to do this. So what you do is you have seen what was inside that. There was linear xyz, angular xyz. So you know the first letter as L. I just press L and I press tab. It gets auto completed. That's what I'm doing. So to auto complete things, there is again one extension known as this gedit.bash rc. If I go inside my gedit.bash rc, you will see this source colcon share are complete. So for this, you will have to install this first, then source it. So it will auto complete the commands. Just for your information. Okay. So let's move our turtle. Let's rotate our turtle. So I'm publishing to turtle1 command velocity. My turtle is rotating. Now in this terminal, let's say in this terminal, let's publish to turtle2. So ROS to topic pub. I am publishing to turtle2 command velocity. No, topic cannot perform functionality of a service. ROS to topic pub. Again, the message type is geometry message only, and I press L, press tab. Now let's move this turtle, rotate this turtle, and also move this turtle forward. So now you can see one turtle is rotating, other turtle is making a circle. Let's see what's happening at the backend. To see what's happening at the backend, what you do, you just do RQT underscore graph. If I press enter, you will see this is happening at the backend. So you can see now two boxes. One is for turtle1, another is for turtle2. One command line I am using to publish turtle1 command velocity to publish to turtle1 command velocity. Another command line I am using to publish to turtle2 command velocity. And the Turtlesim node. Here you can see clear example that a single node can subscribe from multiple topics. And the Turtlesim node is subscribing from these two topics and moving the turtles individually. You can see. So till now, everything is clear. You guys have any doubt, you can ask. Can one command line publish to turtle? No, using one command line, again, a command line acts as a node. So using a single command line, you cannot publish to both turtles. You'll have to publish them separately. Okay. Then answer this question, which I have shared now. Just can you explain once again service? Okay. Okay, so the correct answer for this is one-way ROS to topics are one-way communication channel between nodes. Again, someone has marked as two-way request response system. Okay. Okay. So once again, I am just covering what is a service. So basically, a service is a request response system. There is a waiter. When you go to a restaurant, you place order, you give the order to the waiter as a request. The waiter then accepts the request, goes to the kitchen, brings back the food as a response. So when you placed the order, you placed it, for example, like it's a very lame example, but just to get things clear, when you placed the order, you placed it using your voice. So consider that as a request type. It was a certain request type wherein you placed using your voice, but the waiter brought you food, which is not voice. So response can be of a different type. Depends on the service which you are building. It was a very bad example, but I think it's clear now. So request can be of a specific structure, response can be of a specific structure, and that is the service interface type. We can build our custom interface. We will be building tomorrow and seeing like how to interact using program. So basically, service is a request response type, and I have shown you guys the spawn service. Now let's do one thing. Let's kill this turtle2. Just let's remove it. So for that, there is another service. If I do ROS to service list, if I request type is integer, can response be string, or it should? No, definitely depends on the interface type of the service. Since these are predefined services, so these have a specific request and response type, which we are finding by doing the reverse engineering thing. We are first listing the service, then seeing the service type, then we are doing interface show and going inside it, then we are seeing the request response framework, then we are calling the service and publishing it. So since these are predefined, but request can be different type, response can be different type. Request can be integer, response can be string. As you saw here clearly that when we spawned the turtle2, request was x, y, and theta, but response was string, just the turtle name. So yeah. So ROS to service list. There are services wherein you just place request. There is no response as such, but they do the task. For example, let's see kill service. So we have listed the service. Let's know the type of this service. So again, how do we know the type? We know the type by ROS2 service type. For topics, how do we know the type? For topics, we know the type by ROS2 topic info, then the topic name. So ROS2 service type, I want to know the type of kill. If I press enter, you can see the type is this. Now let me do ROS2 interface show. I want to see the request response structure of it. SRV kill. If I press enter, now here you can see that you only send a request, then there is no response. This is the separator. Then below this you get a response, but here you don't have any response. So we will only send the request. So let's send the request. ROS to service call. We are calling the service. Which service do we want to call? We want to call the kill service. What is the service type of it? The service type is Turtlesim SRV kill. And what is the request type? Request type is name. I press N, press tab, name. Which turtle do I want to kill? I want to kill turtle2. This is the turtle2. I know its name because it was printed. You can see here, turtle2. I want to kill this turtle. If I press enter, the turtle got killed. I did not get any response, or I should have gotten a response, but there is no response, so I didn't get any. Turtle2 got killed. So this is how services work. I send a request, I get a response. So this was about services. Let's see one more service. ROS to service list I'll do. This time I'll do -t. And let's see reset service. Let's reset the entire Turtlesim node. So reset service has this type: std srvs srv empty. So let's call this service. Okay, let's see what's inside the service first, or else you won't be able to call it. So ROS to interface show, I want to see inside std srvs empty. So here you can see there is just calling the service. There is no request as such. There is no response. You just call the service. You don't give any specific request, nor do you give any specific response. So till now we have seen a full-fledged service wherein we give a request, get a response. In case of spawning, in case of killing, we only give a request. We don't get any response. And in case of resetting it, We only call the service. We don't give any request, any response. So let me just call the service to ROS to service call. Which service I want to call? I want to call the reset service. What is the interface type? Interface type is std srvs empty. Since there is nothing inside it, I'll place this bracket. It's empty. If I press enter, it got resetted. New turtle got spawned here. No request, no response. New turtle, everything got resetted. This is how services work. Till now, if you guys have any doubt, just unmute and ask. So the correct answer is the actual data sent on the topic is a ROS2 message, and the data is of a specific type, that is the message type. I don't know. Someone is every time there is one vote for a wrong answer. I guess someone is doing this on purpose. One vote I am every time getting for a wrong answer. Okay. Uh, okay. Then everything is clear till now. So we will we have covered services, spawn and kill, and we have also covered the CLI commands related to services. We have also seen what is RQT Graph. So it is a debugging tool with which you can visualize things. If you guys don't have RQT, you can install this using this command sudo apt install ROS humble RQT Graph. For Jazzy, just change humble to Jazzy. And to run RQT Graph, this is the command RQT underscore graph. We have seen this. So now you guys clearly understand the language which the robot speaks, and you can communicate with them in their own language. So we have covered what are nodes, what are services, what are topics, what are service type, what are messages, what are service request response framework, everything using Turtlesim. And we are also able to visualize things. Now, since we are running short of time, we will be covering how to write our first ROS2 node. So we have covered everything in command line, to interact with the things, and the basic concepts. Tomorrow we will be writing everything using interacting with everything using program. We will be writing our first node using Python. There we will be covering service servers, service clients, how to write your own message type, service type, everything. And tomorrow we'll be covering the two projects using this. So tomorrow might be a long session. It might extend, the time might extend. So just be prepared for it. Okay, so this was it for today's session. If you guys have any doubt, just let me know. No one has any doubt? Okay, if no one has any doubt, how can I download? What do you want to download exactly? Can we add two projects in our resume? Yes, you can definitely add. You can post on LinkedIn, you can add on your GitHub, you can add on your resume. Okay, how can I download ROS in Windows? You'll have to see it online. There might be many resources available to download ROS on Windows. But we won't be covering it because right now I am on Ubuntu, so I cannot show you how to download on Windows. To run Turtlesim, we just have to know the language and the set linear and angular dimensions, right? These two projects will be done tomorrow. Yes, it will be done tomorrow. For those projects, do we need dual boot? VM should be enough for those two projects. Those are not heavy duty projects. It's good that you are having LTS Ubuntu. Okay, so yes, you can use WSL as long as it works for you. Uh, to run Turtlesim, we just have to know the language. Yes, yes. Whatever I showed you, that's it. I I still have some doubt understanding the difference between ROS to service type and ROS to interface show for a specific service. Could you please tell me about that again? Okay, so you have a doubt regarding ROS to service type and ROS to interface show. Okay, so if I do ROS to, for example, let me write it as topic. If I do ROS to topic list, so guys who want to leave can leave. We have covered already. I'm just repeating this. So if you have to go somewhere, you can leave. Okay. So if I do ROS to topic list, these are the topics available. For example, I want to see, let's see this topic, color sensor. Okay. So if I do ROS to topic info, then I want to see this turtle one topic. I want to see the color sensor topic. If I do press enter, you can see the type. The interface type of this topic is Turtlesim message color. So what is this exactly? This you will understand it better tomorrow, but this is what's happening. So from the Turtlesim package, in the Turtlesim package, there is a folder named as message. In that folder, a specific message type is defined. The message type name they have given as color. Just like when we write our Python program, we give the file name. For example, hello world.py. So hello world is the file name. So this is the type name or the interface type name. So now I don't know what is inside this. If I want to interact with my turtle, I have to know what is present inside this. To see what is present inside the color file, the file color.message, I do ROS to interface show. I want to see inside turtle sim message color. If I press enter, you can see this is present inside it, with which really I'll be interacting with the turtle. So you can see here the basic variable type is uint8, which is unsigned integer 8 bits. So it cannot be a negative number. It's always a positive number. 0 to, generally it ranges from 255. 0 to 255. So RGB, I can do this. So this is what interface type means. For example, let's say that I move my, let's say what's happening is, I'll come to the service thing as well. Let's say I move my turtle one. Okay, so my turtle one is moving, but it is making a white path. So let's publish to this topic, turtle one color sensor, and let's see what happens. So to publish to this topic, I need to know these things. ROS to topic pub. I want to know to which topic I want to publish. I want to publish to turtle one color sensor topic. And what was the interface type of the topic? The interface type was turtle sim message color. And what was inside that? This is why we need to know what is inside that, or else how will we command? So inside that was RGB. So I pressed R, values came. Now let's make the track as blue. So let me just give this value as 255. If I press enter, okay, why is the color not changing? I guess, let me put it as red and green and try. Let me see. I don't know what is this exactly for, but most probably track color should change, but it is not changing. I guess it's for something else. But this is why we do need to know the interface type and what is inside that something might be changing. I'm not able to notice it. Change the track color. So this was about topics. So let's come to services now. I guess we can change the track color using services. So again, just like we do for topic, we do for service, we do ROS to service list. If I press enter, you have this turtle one set pen. I guess most probably track color changes with this turtle one set pen. So how will I know? like how will I interact with this service? I don't know anything about this service, what message to send, what is the response, request response structure. So to understand that, I need to know the type of the service type. So for that, to know the message type, I did ROS to topic info. So I got the message type. But to get the service type, we do ROS to service type, and I do turtle one set pen service. For example, I want to call. So set pen uses this type. Now I don't know what's inside this type. So again, I will do ROS to interface. So basically, I want to, these are interfaces. This is service interface, that was message interface. I want to see what is the exact interface type. So what ROS to interface type, I want to see inside the interface. ROS to interface show, not type. ROS to interface show, I want to see inside Turtlesim SRV set pen. If I press enter again, so here you can see that this again is showing RGB width. This is the width of the line which we want to create, and this is off. I guess it will turn off the tracks. It will not show anything. Not sure, but this is what it is. So this is the request framework. This is below this, below these three hyphens is the response, but this service doesn't have any response. So we only will be sending the request. So how will we send the request? I will do ROS to service call. Right now we are using command line interface. So we are sending the request using command line. Tomorrow we will be sending the request through Python node. So ROS to service call, I want to call, what was the service name? Turtle one set pen, I guess. Set pen. Okay, what was the service name? I forgot. ROS to service list. Turtle one set pen S was small, so ROS to service call turtle one set pen. Interface type is Turtlesim SRV set pen. What is inside? This is why we need to know what is inside to send the request. Inside is RGB. Okay, so let's send this as 255. Hopefully it should draw a green track, and let's send the width as 2. If I press enter, now you can see that our turtle is drawing a green track. Okay, I don't know, its width is not increasing. Let's try again. This time let's make it draw a red track. So I will put red as 255. So you can put values between 0 to 255. You cannot exceed that those values. And let's try to keep the width as 5, for example. If I press enter, now you can see the turtle is drawing a red track and the width is also increasing. If I and you can see that it made a request, it got a response, but there wasn't anything inside the response, so we are not getting anything. So let's try to put it as 1 and see what happens. Most probably the track will get off. It's just the previous track which is it's showing, most probably. So this was about services. Call it like publishing. Yeah, basically you are sending a request to the service server. It is processing your request. Your request is getting displayed here, and then it is sending a response that it was successful or not. Okay. Are we going to do parallelly projects along with you? If you can, it's like very good if you can do parallelly the projects. How do we get to know about working of any service or topic shown in this list? I mean, do we have all of this in documentation? You might be having, but that's what I showed you from the beginning. You want to see how to, that's what I'm showing right from beginning, that how to use a service. the pipeline I am explaining. You do service list, then you get to know the service type. Once you get to know the service type, you see the interface type, what's there inside it. Then you use that interface to call the service. You get a response. That I don't think you need any documentation for it. If I am using VM dual boot Ubuntu, will I lose everything in the VM? Not necessarily. Not necessarily. If you're dual booting and if it is done fine, then everything can remain intact. But in my case, when I did dual boot, everything, in my case, I lost everything. So just have a backup. Okay, so I think you guys have understood. Let me ask you guys a last question, and then you guys can leave. Okay. So this time, I guess the one who was giving wrong answer every time has left the meeting. So I am getting the correct answer. Okay. Uh, okay. So I guess you guys have understood it clearly, and I would also encourage you guys, folks who are on LinkedIn, just take a screenshot of this webinar and tag me as well. It would be really great if you can do that. And this was it for today's session. We will see you guys tomorrow. Just keep a bit of extra time tomorrow because the session might extend. Okay. So you guys don't have any doubt, then I am ending the session now. Let me stop the recording.